All right, let's review. Let's go to page 29.
Oh, but. No, I was like.
He's in way.
Okay, guys, page 29 in your packet. Go ahead and start these problems, and I'll show the answers and go over them once you guys have a chance to try it. So test it tomorrow once you guys can have a chance to try these problems on your own.
Is your help session tomorrow?
7:15 tomorrow morning. It's up until, well,
And we can come in anytime.
yeah.
You know. That's correct. That's the only.
But I'm gonna do that.
Oh, I got, I do have.
If you have a big one.
And I don't know. We both did.
Okay, guys, go ahead and start number 1. Okay, so order pairs to component form. We can have one tomorrow. Okay. So it's important that we know where the initial point is and where the final point, where the terminal point is. So we have to do x minus x1, y minus y1. It's not always in alphabetical order. It's really depending on what they say is first and which one is last. So whatever comes first is your initial point. Whatever comes last is your terminal point. So make sure that you don't automatically assume that it's always alphabetical order. They're always going to tell you which order to use. Unit vector, you have to just take that component form and involve I and j. But here the difference is yx, right? So we have to create a different set of So number three, component form is gonna be different than number one because y is the initial point and x is your terminal point. Well, I wouldn't always go after that. I would go through the work, right? This is x2, this is x1, y2, this is y1. Because here, y is your initial point, x is your final point.
So what I'm just, yeah, vectors is that when you turn to like I, okay?
That's right, yeah, you just take your component form and you just put I and J. But addition or subtraction between the two terms.
How many questions is on the test?
It'll be just front and back. So,
Like this?
yeah, like this, and also like the worksheet 3 that you picked up yesterday.
Try to make it second one.
Right, because this is second quadrant, right? So -3, 4, that's in the second quadrant. So I know that -53 is not, that's not a degree measure, that's standard position, so I gotta involve 180. Yeah, I always imagine where that vector is pointing. And if I know which quadrant it's in, I'm just always going to make a decision based off of which quadrant it's going to be in, and then make sure that my degree is landing in that correct quadrant. Okay, magnitude, Pythagorean theorem. Find the angle between two vectors, you got to involve inverse cosine. Again, I'll provide that formula for you on the test. I'll try to. Your calendar sheet. Yes, this, if you have that in front of you, but this. I can bring that screen. Yeah. Control. Get comfortable with something. That's all the data, so that you get there's still some. I think it's pop out. It's -5 times 4 plus -1 times -20 plus 3. That's right, you don't have to do any adjustment, whatever you get for theta, that's your answer. You only have to involve adjusting if you're doing inverse tangent. If you're doing inverse tangent, then yeah, you got it. Here, this formula, no adjustment needed. Okay, so make sure you're comfortable with number 5, with the dot product, with knowing how to involve the formula. Make sure that you're multiplying your magnitudes together and that you're doing your magnitudes correctly. And then finally, you have to also have to involve inverse cosine, right? We gotta, that cosine that's in the formula, we gotta involve cosine somehow. And 6 should be pretty straightforward. We've been doing that for a while now. Go down to 7 and 8. Oh.
Also find it.
Distribute a negative through. Yeah, yeah. So you do plus and then negative to the positive one. If you want to. Based off the distance. I'll start moving to the left, then I gotta move that down one. Yeah. And so that's your first. So, easier to make that your plus so that you can return the same. So I agree, second factor, that's not his last three dollar. Like, now it's important that you started here and you ended here, you know, I want the arrow to point in this direction that you're what it is. Yeah. So this is the same thing as this. Because we're going -7 to the left and not looking up the down. Okay, try 9 and 10. Next page, let's work on the word problems. Pilot directs his plane to fly at a bearing of 210 degrees. So I would like to convert this to standard position. So I can have something that's more straightforward. So how do I convert from bearing to standard position? Yep, so 450 minus 210. All right, so now it's easy, right? You can find your theta, you have your magnitude, component form. Four hundred 60 miles per hour, that's your magnitude. And then your theta is 240. Part B, we're going to carry that information down and use that for part B. Yeah, so 450 minus 210. Oh, sorry. Oh, no. 460 miles per hour, that's your magnitude. The formula for bearing is 450 degrees minus 200, minus, yeah. So it's over here. Bearing, measure minus 450 degrees minus position. Or sorry, their position is 450 degrees minus 200. Okay, part B, an 80-mile-per-hour wind blowing in the direction of south 50 degrees east is pushing the plane off course. Find the ground speed and direction of the airplane that results in path. So this is more straightforward because I have the plane that's moving in this, that's trying to move in this direction. And then the wind is going to blow it off course. So this is just the plane vector plus the wind vector, and we're trying to find the resultant vector. But we do have to convert this south 15 degree east into standard position. So how do we do that? So we start south, what degree measurement is south? Yeah, 270, and we're going to move to the east. So we're going to end up in the fourth quadrant. So 270, what? Plus 15. Yeah, that's going to make it land in that fourth quadrant. So the plane vector plus the wind vector equals the resultant vector. And then we just find all the information that we want from the resultant vector, the magnitude, the direction using inverse tangent.
Okay.
Right, so
That's all it was. 450.
Right. If this is true bearing, then you do 450 minus that degree measure. But here, they're telling you exactly what to work with. So they're saying start south and then move 15 degrees east. That's how we end up with 285. That's from part A.
Oh.
Yeah, so we're gonna drag that part A down since that's the, yeah. That's right, yeah, because the plane vector plus the wind vector is gonna, this is how the plane is actually gonna point in this direction because the wind is gonna push it off course. Okay, number 12, I think we're familiar with number 12, but the way the problem is worded, it's going to ask for a different set of information. Okay, so a new scoreboard is being placed in the gym. It will be supported from the ceiling by 2 cables. Each cable can withstand 150 pounds of tension. If the scoreboard weighs 250 pounds, what's the largest possible measurement for the angle the 2 cables can make with each other? So the 150 pounds is talking about the cable themselves. Now, we know the scoreboard is going to be 250 pounds, which means that the vertical component is going to be what? To support that 250.
125.
Okay, each cable can withstand 150 pounds of tension. So 150 is going to be now the wire themselves. It says, what's the largest possible measurement for the angle that the cable, for the angle that the 2 cables make with each other. So what we can do is we can find theta. And then we can kind of just go to the side and just focus on this problem here, right? So we have the 150 pound from the wire, the vertical component, which is from supporting that the weight of the scoreboard, and we can find theta.
I think what I'm looking for would be like one between the.
It is, yeah. So, but we're gonna find this first, and because there's symmetry involved, we could use this 180 to help us find that.
Okay, so we're still finding that.
Yeah, ultimately, we're still trying to find that, but we're gonna just focus on this piece. Easier to focus on the right triangle. Okay, so what can we use to solve for theta? All right, so sine of theta equals opposite over hypotenuse. We gotta use inverse sine to get theta by itself. What's theta equal to?
Just 256.
Mhm. So if this is 56. Then the true theta that we're looking for, we can do 180 minus 56 minus 56, and we get that theta in between, 56.443. Okay, 13. A pilot needs to plot a course that will result in the velocity of 520 miles per hour. So you see that word result, that's hinting that this is your resultant vector. If the wind is blowing at 65 miles per hour, find the direction and the speed that the pilot should set to achieve this resultant. So this is one of those backward problems where you have the resultant, you have the wind, but you're working backwards to figure out whether it's the plane or the pilot course that it needs to set. So we know that plane plus the wind is equal to the resultant vector. I'm trying to find the plane vector, so it's going to be the resultant minus the wind vector. Okay, so the resultant vector, velocity is 520 miles per hour in the direction south 32° west. So that means I'm starting at 270 degrees, right, west. So which quadrant am I going to end in? Third quadrant. So it's got to be 270. What? Minus 32, right? That's the only way I can land in that third quadrant. 270 minus 32. Okay, so you're going to get your resultant vector in component form, get your wind vector in component form, and you're going to subtract them. So once you get to your plane vector, then you can use inverse tangent to get your direction. And then magnitude, you can use Pythagorean theorem. Okay, any questions? Okay, we still have some time available, so let's see if we can spend the next 10 or so minutes starting on worksheet 3. Sheet 3. Does anyone not have worksheet 3? This is from yesterday. Yes, I like. So you guys didn't think about from yesterday. Let me see. Please attached. Guys, the key is attached.
Oh, I don't think it did.
Yeah, this first sheet.
Very fun, all right. So some good.
Yeah, no, that's how it was like, it was freaking out.
Yeah.
Don't take the show, I might. Just, you know,
And if you your works and make a mistake, then you can post the credit, that's not a mistake. So it's up to you. So if you get something else, you can post your credit, that's the good work.
Say, why do this?
Because this is why that's, now it's changed, so why is the initial point, that's again, minor things, things like that. If we use.
I can't see it, these things. You got to give me an answer.
There's no fraction, just the divide.
No, there is a fraction.
Wait, what? Here, you should. Yeah, please do.
So it's the alpha. So my goal is basically one. And then what?
That's so much work.
Yeah, let's say that you have. That makes work so we can. If you have to read this.
All the ivories. Let's do it.
Hold us, but it's not on the class that's big. I realized you're just. Oh, I understand. That's my skill.
Oh, now I got it. Okay. No, really, how much was it?
Each of the ivories.
You're fine. I can figure out here's what it's.
Just do.
I'm not blood. No, yours. No, you're not. That's what I said to you. No, I am not. That's one of those things. I have a little first.
Don't worry.
Oh, yeah.
Yeah, I
What's
got
the big size? What's really? Yeah. No,